Hello everyone. In this video we're going to be dealing with a radical expression. We have x squared minus 18x equals 17 times the square root of x, and we're going to be finding the value of x minus square root of x. So we're going to find the x values, or maybe we're not going to find them. So I'll be presenting two methods, and let's start with the first one. My first method can also be called no pain, no gain. First of all, notice that if x is equal to 0, then this equation is going to be satisfied because 0 equals 0. And if you plug in 0 for x, then you get 0 as well. So our expression is going to equal 0 if x is equal to 0. Now let's go ahead and take a look at the case where x does not equal 0. What happens in that case? So I'm going to go ahead and square both sides of this equation. So square this and square that. When we square what's on the left-hand side, we get x to the fourth power minus 36x cubed plus 324x squared. And on the right-hand side, we get 289x. Now let's put everything on the same side and write this as a quartic equation. Now we have this expression minus 289x, and the whole thing is equal to 0. Awesome. Now, notice that in this equation, x can be factored out. And also, another thing that I want you to notice, and I keep saying this in different videos, always check the sum of the coefficients and the sum of the odds coefficients and the sum of the even coefficients, because x equals 1 and x equals negative 1 could be potential solutions. And in this case, that happens to be the case, because if you check 1 minus 36 plus 324 minus 289, you're going to notice that 1 plus 324 is 325, and negative 36 plus negative 289 is also negative 325. So this gives you 0, which means x equals 1 is a solution. But not only that, a more obvious solution here is, I think, x equals 0, because x can be factored out. So that's kind of nice. And to keep a long story short, to save you all the trouble, I'm going to factor out an x, and I'm going to factor out an x minus 1, and I'll give you the other factor, all right, for free. The other factor is going to be quadratic, and that is going to be x squared minus 35x plus 289 equals 0. Now, it's not hard to find once you know that x and x minus 1 are factors. The rest is fairly easy, actually. Okay. Now, let's go ahead and take a look at the solutions of this equation. X equals 0 is a solution, but we already considered that. X equals 1 is a solution. Okay, we're going to check that. And this one is quadratic, so that gives us two solutions, and those solutions are x equals 35 plus minus the square root of 69 over 2. So we kind of get like 3 candidates, and we're going to check all of them. Because we had a radical equation, we have to make sure x is positive. It satisfies the original equation, because we might have introduced extraneous solutions because we squared both sides. Okay? Now, if you go ahead and plug in the x value, for example, what happens if, and let me rewrite my original equation, x squared minus 18x equals 17 squared of x, and we got x equals 1. But if you plug in x equals 1, here you get negative 17, here you get positive 17. Obviously, they're not equal, but they just come up because of squaring both sides. So x equals 1 is not a valid solution. We're going to discard that. How about the other ones? Well, if you do the same check with this one, you're also going to notice that this does not work. You can go ahead and check that. It's not too hard to check, but I'm going to leave it to you. And I'm going to check the other one. So this doesn't work either. How about the plus version of this? I don't know why this is happening. Okay. What happens if x is equal to 35 plus the square root of 69 over 2? Let's go ahead and plug it in, and it's kind of fun exercise. So our expression was x minus 18. Actually, not x minus 18. We're trying to find the value of, okay, so here's what we're going to do. So when we plug in x equals this number, it works. So let me also save you that trouble as well. But what happens if you plug it in here? All right, so let's go ahead and talk about that. If you plug it in here, you're going to get the following. you'll get 35 plus, oh, okay, I don't know why this is happening. 35 plus the square root of 69 over 2 minus the square root of 35 plus square root of 69 over 2. So we have a nested radical here, so we're going to denest it. How do you denest this expression? Let's go ahead and talk about that. That's kind of fun to do. Now this expression obviously can be written like this. We can separate the top and the bottom. And now multiply this by root 2 over root 2 to get rid of the radical 2. And also, we want to get something nicer inside. I'll show you now. If you get an expression like this, this one is easier to denest when there's a 2 inside the radical. So now we're going to think about it this way. Notice that 69 is 69 times 1, and 69 plus 1 is equal to 70. So this can kind of be written as 69 plus 1 plus 2 times the square root of 69, which is 69 times 1. And that just becomes a perfect square. And that is actually the square root of 69 plus 1 squared. But I have to square root it, divide by 2. But that's a positive expression. So this turns into square root of 69 plus 1 divided by 2. Now remember, that's just part of the expression. So I'm going to go ahead and plug it in here to find x minus square root of x. X is equal to square root of, not square root of, it's 35 plus square root of 69 over 2 minus the square root of x is equal to this, which is square root of 69 plus 1 over 2. They have a common denominator, so the answer becomes 35 minus 1 over 2, which is 34 over 2, and that is equal to 17. So my expression for the only x value that works is going to equal 17. Now let's go ahead and take a look at the second method. Obviously, second method is going to be more interesting. So we have this expression, and notice that 18 and 17 are 1 apart. So I'm thinking about splitting the 18x into negative 17x plus negative x. And this kind of allows me to do factoring. Here's how it works. I'm going to leave the x here and put the 17x on the right hand side. And now we have a common factor. X is a common factor here, and 17 is a factor here. Okay, let me do it that way for now, and then I'll do a little bit more. But notice that there's more common factors than what we already have, and it kind of helps you factor this expression and simplify. For example, x plus square root of x has square root of x as a common factor, and x can be written as square root of x times square root of x. Therefore, it has the same thing. So we can kind of take out a square root of x and write it as this. And then on the right-hand side, we can kind of take out square root of x, and we can write the inside as square root of x plus 1. Now, this is pretty good because now we can go ahead and factor out or simplify or cancel out square root of x, because we know x does not equal 0, so we're allowed to divide both sides by square root of x. And then we can also factor this by using difference of two squares. Why? Because we have square root of x plus 1 on the right hand side. So that is the motivation for squaring this, kind of like a forceful thing to do, but it sometimes helps. So we're going to go ahead and factor it. And obviously, it's a different field that we're using, which is the irrational numbers. Anyways, so now, or just reals, whatever, square root of x plus 1 cannot equal 0, because if x is real, then square root of x plus 1 is always going to be positive. Therefore, we can also divide both sides by that. And that gives us something real cool, because if you distribute, you're going to get x minus square root of x, and on the right-hand side, you're going to get 17. Which is what the answer is. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.